All right, 7.4, trapezoids and kites. Kites really isn't a very commonly used term in geometry, but we're going to cover it for the purposes of this class. So if you never hear it again, so be it. But kites are kind of a thing of the past. Trapezoids and kites, here we go. Yesterday we learned about rhombi or rhombuses, four congruent sides, rectangles, opposite sides congruent with four right angles, and a square is both of those. 90-degree angles, and all four sides are the same. So when we talk about these, a square is both a rhombus and a rectangle, and all three of them are parallelograms. But new today is trapezoid. A trapezoid is with exactly one pair of parallel sides. Okay, I have two bases that are parallel to each other. I also have the legs of the trapezoid. You can think about a trapezoid as looking like a triangle whose top has been cut off. Like if you continue to etch these legs up, eventually you'd see a triangle, and the top part's been sliced off. Okay, an isosceles trapezoid is like an isosceles triangle where both legs are congruent. So we have two legs that are the same value. Now there's some interesting rules that apply to isosceles triangles. Not only are both of the sides congruent, but now both of the top angles are congruent and both of the base angles are congruent. These are both bases, by the way. They're isosceles. It's a trapezoid, base and base. So the two adjacent base angles are congruent. So that's kind of interesting. You'll be tested on this. Make sure you know that the base angles are congruent. All right, so also working backwards, if I give you a trapezoid and I tell you that these two angles are congruent, then you can therefore say it is an isosceles trapezoid. You can also do that if the diagonals are congruent. Notice how it says if and only if. It's a biconditional statement. So if it's isosceles trapezoid, then the diagonals are congruent. Or if it's a trapezoid with congruent diagonals, then it is an isosceles trapezoid. Now let's talk about the mid-segment or median. The mid-segment of a trapezoid is the segment that connects the midpoints from both sides, both of the legs. So N is the midpoint of CD and M is the midpoint of AB. If I connect those, that's the median or mid-segment. The way we find out how long that is, we add the two legs, B1 and B2 are the bases. Sorry, I totally misspoke there. It's the bases. We add base 1 and base 2, my fault. And once we add those together, we find out half of that, and that's how big the mid-segment is. So we have the formula for the mid-segment. It's on the cheat sheet. I'm familiar with this document. Very important. So for the mid-segment, here's the formula, and here is the picture of example 7.20 in your notes. If I plug those values in, it's called substitution. So I plug them into the formula. Base 1 is 12, base 2 is 6, and x is the mid-segment. I simplify the numerator, or I just addition, simplify combine like terms. And then I simplify the fraction, and I get x equals 9. So 12, 9, 6. Makes sense? All right. Now, if it's non-isosceles, it doesn't matter. The property still applies. So here we have the mid-segment, because this is the midpoint. Right here, you can see it cuts it in half and cuts it in half. Either way, it's still going to be parallel, and it's still going to be following this method. So I take my formula, the mid-segment formula. The mid-segment, I know it. It's 7. But what I don't know is what base 2 is. So I substituted my information. 7 goes in for the mid-segment, 4 for base 1, x for base 2, and now I get to solve. I multiply both sides by 2 to get rid of the fraction. I subtract 4 from both sides, and I get x equals 10. All right, I have a problem just like this on your test. Here's another one for the mid-segment. Again, I plug in my values. 8 is the mid-segment, it goes here. 11 is base 1, x is base 2, I plug those in. I multiply both sides by 2. I subtract 11, and I get x equals 5. All right, so example 2.23. Again, I substituted my answer. 7 is the mid-segment. It goes in for the equals. X is base 1, 9 is base 2, and I solve. Multiply both sides by 2, subtract 9, equals 5. Okay. Mid-segment, base 1 and base 2. Now here's where it gets more complicated. No longer am I using single numbers. I'm now using complex variable patterns. So now I say, what's my mid-segment? It's 5x. It goes right here. My base 1 is x plus 12. And then my base 2 is 7x minus 2. Well, now my first step is going to be substitution. And then I combine like terms or simplify the numerator. I multiply both sides by 2. I subtract 8x over, and I divide both sides by 2, and I find out x equals 5. Okay, so this part here is all just algebra. This part, setting up the mid-segment formula, is new to geometry. Okay. Now, we have what's in 7.25, we have an isosceles trapezoid. Remember, there's special rules about isosceles trapezoids. All right, I'm telling you right here, BAD, that's this angle here, BAD, is equal to CDA. Okay? Well, all right, and if that's true, if they are congruent, then the reason for that is the definition. That's the definition. Isosceles trapezoids has congruent base angles. Okay? Then I can substitute in my 70 degrees for BAD. Okay? And then also that means that it's the transitive property. If BAD equals 70 and 70 equals, and BAD, you look at the reason there, I can just drop off the BAD and get that through the transitive property. Okay. All right, so now I'm looking at this as being, as being 70 as well. So now I say that CDA, this guy right here, plus DCB up here has to equal 180 degrees. Well, these are consecutive interior angles. They form the bucket. So when they do that, I end up with consecutive interior angles. I substitute in for the CDA as 70, and then I subtract 70 from both sides, and I get DCB as 110. There you go. So, yeah, it's example 7.25. You'll have a problem like that on the test. So again, reviewing the mid-segment formula. If it's an isosceles trapezoid, or not just isosceles, any trapezoid, we connect the midpoints and we can find that length by adding the bases and dividing by 2. So you can think of a trapezoid like a triangle being with the top sliced off. Okay, I've got here 8 and 6 divided by 2 equals 7. Okay, I can get 14 divided by 2 equals 7, so x is 7. Now, what's interesting is we can do this for all sorts of triangles, but I'm leading you kind of into what happens when this piece gets smaller. So before it was 8 and 6, and the middle part was 7. It was 8, 7, 6. Now, if I make it smaller, I cut the triangle higher up, and I have 8, 4. Now the mid part is 6. It was 8, 7, 6. Now it's 8, 6, 4. If I go any further and I say it's a 2 up here, now it says 8, 5, 2. But what's interesting is if I don't cut off the top, let's say I have an actual triangle. Okay? We're no longer dealing with a trapezoid, now we're dealing with a triangle. And now how big is the top part of our quote-unquote trapezoid? It's a 0. We didn't cut anything off. And that makes x equal to 4. So interesting that the base of this triangle is twice as big as the base of this triangle. This gets back into similar triangles and side angle side similarity, scale factor of 2. Okay, kind of a refresher from previous times. So example 7.26. I've got this trapezoid here. I plug in my mid-segment formula. That's substitution. I simplify my numerator and I simplify my fraction, and I get x equals 12. Really good stuff here. Really pretty easy concept, but still can cause a lot of difficulties. Okay, so in example 7.27, we've got a triangle. It's no longer a trapezoid. which is why I have here a 0 for my other base length. Okay, so I substitute in, simplify the numerator, and simplify the fraction. Notice how 12 is twice as big as 6. If you have a triangle situation like this, it's a similar triangle with a scale factor of 2. That's all it is. So this is just interesting how we can compare similar triangles and trapezoids. Okay, so now we're going on to a kite. A kite, like I said, isn't very used often, but basically it's a quadrilateral with adjacent sides, right? Two pairs of adjacent sides that are congruent. Not all four, not opposites, but next to each other. Okay, and the reason they call it a kite is because obviously it looks like a kite that you would fly in the air. So a kite has some interesting properties. Diagonals are perpendicular, very similar to a rhombus or a square. You will not be tested on this thing. This is more just so you can see it and know a little bit about kites. The opposite angles are congruent one pair. Okay, where the two congruent pieces, non-congruent sides meet, these two angles are congruent. All right, so what are the main properties of a trapezoid? This is where we got to talk about one set of parallel lines. Okay, you've also got the mid-segment, right? We can talk about the mid-segment there. We can talk about different properties. Main properties of kites. We have adjacent sides are congruent, opposite angles are congruent, and the diagonals are perpendicular. Okay. So, special quadrilaterals. I want to show kind of a diagram, a flow chart. Okay, so if we have quadrilaterals, well, if I want to get more specific, I can say, well, it's not just a quadrilateral, it's a kite. A kite is a special kind of quadrilateral. Or if I'm given a quadrilateral and I end up finding out, hey, look, these two are congruent and these two are congruent, that makes it a kite, and that means we have more information, okay? So this is kind of how we do it. Now, if I want to go a different direction, let's say a different kind of special quadrilateral. If they end up having one set of parallel sides, it's a trapezoid. Now, if I have a specific kind of trapezoid, I get an isosceles trapezoid because the legs are the same length. Or I can go and say, what if I have two sets of parallel lines? Notice how here we have no parallel lines. Here we have one parallel lines, and here we have two sets of parallel lines. So, a parallelogram can be further broken down by side or by angle. If we look at it by angle, a special parallelogram based solely on angle is a rectangle. Notice how we squeeze this parallelogram around until we get 490-degree angles. It's a rectangle. Or we can squeeze this parallelogram by side and turn it into a rhombus. A rhombus is a parallelogram that has been squished over until it just so happens that all four sides are the exact same length. Now, if I get both of these, if I have a rhombus and a rectangle, I combine these together, I end up with a square. Now, what's interesting is if I go up the chain, then it's always true. A square is always a rectangle. It's also always a rhombus. All three of these are always parallelograms, and parallelograms are always quadrilaterals. Now, if I start heading back down, let's say a quadrilateral. Is a quadrilateral always a parallelogram? No. A quadrilateral could be a trapezoid or it could be a kite. So going down the chain, it's a sometimes. A parallelogram is sometimes a rectangle, sometimes it's a rhombus, sometimes it's neither. So going up the chain, it's always true. Going down the chain, it's not always true, sometimes. So a square is always a rhombus and it's always a rectangle. And a rectangle is always a parallelogram. And a parallelogram is always a quadrilateral. Similar to the apples or fruit of two hard apples. All right. Review of definitions and theorems covered on the test. So this is what we're going to review really quick, what we need to know about for the test. All right, quadrilaterals, opposite sides are congruent. Okay, a parallelogram, opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. All right, so now we're going to go backward. We're going to try and prove that an object is a parallelogram. If the opposite sides are congruent, then it's a parallelogram. If the opposite angles are congruent, then it's a parallelogram. Kind of the same rules. If consecutive angles are supplementary, then it's a parallelogram. If the diagonals bisect each other, then it's a parallelogram. All right, further, if one pair of opposite sides and one pair of opposite sides, if it's congruent and parallel, then it's a parallelogram, okay? All right, so here's proving quadrilaterals are parallelograms. Those are your 6 ways of proving it. If we go on further, we can talk about the rhombus corollary. A special kind of parallelogram is a rhombus. It has all 4 congruent sides. A rectangle is the special kind based on angles, where it has 4 right angles. A square is both a rectangle and a rhombus. It matches both of those criteria. It has 4 right angles, and it has 4 congruent sides. All right, a parallelogram is a rhombus if and only if the diagonals are perpendicular. This is another thing we covered yesterday. We have a rhombus, we have a perpendicular diagonal. There you go. And it goes both ways. It's a biconditional statement. All right, so for a rectangle, diagonals are congruent. Each piece is congruent, and the whole, AC and DB, are congruent. For a trapezoid, we have the base angles are congruent. So we have A is congruent to B, and D is congruent to C. We also have the legs are congruent. All right. Working backwards, if I have a parallel line and these base angles are congruent, then we know the whole thing makes up an isosceles trapezoid. The midsegment theorem. Again, this is going to be on the test. You need to be able to find the length of the midsegment. Also, from isosceles trapezoids, you know that the diagonals are congruent. All right. So there's some extra practice problems on page 28 of your notebook. Take a moment to work on those. Most of these questions are on the test, word for word exactly how you see them. I would study them in great detail. So, the shapes on your test. So you're going to see all of these shapes and their names on the test. You're going to see trapezoid, specifically isosceles and a trapezoid. So you don't need to worry about memorizing what an isosceles trapezoid looks like, because it's going to be on there for you. So let's talk about some of these shapes. Let's see. Use the shapes whenever you're not sure what the correct answer is. Let's look at the shapes. Both pairs of opposite sides are parallel. Which of these shapes does that match? Both pairs of opposite sides are parallel. Well, that's going to be parallelograms. And since squares, rhombi, and rectangles are considered parallelograms, they are included also. The only one that doesn't count is trapezoids because they only have one set. So here, both pairs of opposite sides are congruent. Again, that's the definition of a parallelogram. So all 4 of those apply. Both pairs of opposite sides are congruent. Now, that's also a definition of a parallelogram. So we can circle all 4 of those, or we can include all 4 of those. All sides are congruent. Ooh, now this changes things. All 4 sides are congruent. That is only applicable to rhombuses and squares. All right, so has all 4 right angles. Again, not all parallelograms are that way. Only rectangles and squares are that way. At least one pair of opposite sides congruent. At least one pair of opposite sides are congruent. That is the same as a parallelogram, but it includes an isosceles trapezoid. If it has at least one pair, isosceles trapezoids have one pair. They're right there and right there. So they get to be included in that little group. Study that for the test. So, diagonals are congruent. Well, we know that a parallelogram doesn't necessarily have that true, nor does a rhombus, but a rectangle does, and a square is a rectangle, so that counts. So those 2 are in. An isosceles trapezoid, we have that rule that the diagonals are congruent, so we conclude those 3 are our shape. Diagonals bisect each other. Well, that's true for any parallelogram. All 4 are included. Diagonals are perpendicular. Now, that's only a special kind. That only includes rhombuses and squares. Go over this a lot and practice. Make sure you know each of these specifically. Has 2 pairs of congruent angles. 2 pairs of congruent angles. That is parallelogram, opposite angles. Rectangle, square, and rhombuses are all parallelograms, so they're included. And then isosceles trapezoid has the top base angles and the bottom base angles. are also congruent. Each diagonal bisects two angles. Well, that only works for a rhombus and a square. That's the definition of a rhombus, and since a square is a rhombus, it counts. All right, exactly one pair of opposite sides are parallel. Now, it says exactly one pair. That has to be only a trapezoid. So both kinds count. A quadrilateral is regular. Ooh, remember how we talked about regular quadrilaterals? That is only equilateral and equiangular. That makes it a square. You're only one. This is one of your test questions, by the way. A regular quadrilateral is called a square. All right, some joke I didn't get. All right. Oh, geez. May have made a mistake. All right, some fancy picture. Oh, man. Messed up. All right, now I gotta go find where I lost my place at. Oh, I passed all those. Okay. Yes, a square. Where'd it go? There it is. All right, that's the other test questions. We can delete that picture. All right, interior angles of a quadrilateral. Don't forget our interior angles rule. If it's got four sides, then we take n minus 2 and times it by 180. So 4 minus 2 times 180 gives us 2 times 180, which gives us 360. Okay? So the measure of the interior angles of a quadrilateral add to be 180. Summarize what you learned today. Should be a full summary. We had a ton of new information today. I will be looking for a good full summary. All right. You now know enough to do problems 11 through 14 as well as all the others that I've shown, which is basically most of the review worksheet. This will help you on your homework for these problems here. So we just did trapezoids and kites and special quadrilaterals. Tomorrow we're doing areas of quadrilaterals and circles, and we're doing geometric probability, which is really, really fun. Okay, remember, no late work. Everything's due Friday. Do not forget. Saturday, November 1st. Make sure if you want to come in to retake Chapter 7 test. Oh, it's your last chance to take it for the first time. If you miss it for whatever reason, you can't take it on any time after Saturday. Sorry. That means if you miss it all this week, then Monday is your only chance to test. We won't be retesting after that. Hope that made sense. It didn't really to me. That's okay. There is 7.4.